7, section 1. This is day 1, common logarithms. So our common log, the logs we've been dealing with are not common logs. So the common log is log base 10. So if we have a log base 10, we typically don't write it. They just write log. So when you see log 5 here, like in example 1, that's common log. That's log base 10. And that's the log that you find in your calculator. So for these log base 10s, you just plug them in your calculator. So log 5, and we get 0.6990. Log of 0.3, negative 0.5229. And again, we're going to round a lot of these off because the decimal's going to keep on going. And log, common log of 10, or 7, log 10 of 7 is 0.8451. So logarithms, remember, it's just a way to write exponential forms, okay? So we're rewriting those in different forms with exponents. Take a look at example 2. It says amount of energy E in Earths that an earthquake releases is related to the Richter scale magnitude M by the equation log E equals 11.8 plus 1.5 M. Use the equation to find the amount of energy released by the 2004 Samaritan earthquake, which measured 9.0 on the Richter scale and led to a tsunami. So let's take a look at this equation. So we're plugging in our Richter scale here. The measurement is 9, so that's going to get plugged in here for M. So we have log E equals 11.8 plus 1.5 times 9.0. So we simplify that. Again, we can rewrite this. Okay, to solve for E, we can rewrite this. Remember, this is base 10, so the base is 10. Exponent is here. There's my exponents. So I'm just going to rewrite the whole thing so you can see where it went. 11.8 plus 1.5, 9.0 equals E. So we can simplify that down. All of this is 25. So we're looking at 25.5. So we're looking at 10.5. So 10 to the 10.5. I'm sorry, no, 10 to the 25th. Sorry. Again, 10 to the 25th point 5 equals our E. And 10 to the 25th point 5 in our calculator is going to be scientific notation 1.995 times 10 to the 25th power. A lot of energy going into that. Our last example, or our third example here then on this page, again, if both sides of an exponential equation cannot be easily written as powers of the same base, you can solve by taking the log of each side. So when I take a look here, example 3, we're going to solve these exponential equations using the logarithms. So we're just going to plug these logs in so I can say that this is log, and we're just going to use the natural log. Log 4 to the x power equals log 19. And again, remember our rules. Exponent, we're going to take that x and put it out front. Now we have x times natural log of 4 equals natural log of 19. And then we can solve by dividing by log 4. So log 4. Now we can plug this directly in our calculator, and x on the left simplifies to 2.124. 2.124. Again, we can plug log 19, divide log 4 into our calculator. So again, can't get the exponent bases to be the same, so we're going to log both sides. So log of 3 to the x power equals log 15. Now again, as you do these, you can kind of start jumping ahead and maybe skipping a step here or there. Exponent x comes to the front, so the x log 3 equals log 15. Again, we're going to divide now by log of 3 on both sides. Those cancel. X is going to then equal so log 15 divide log 3, 2.465. 2.465 for letter B. Last one, example C here. Again, we're logging both sides. Log of 6 to the x power equals log 42. Again, x goes to the front. X log 6 equals log of 42. And dividing then by log base or log 6. So logs cancel. X 42 log 42 divided by log 6 equals 2.086. Alright, so those are your section 6 day 1 notes.